use quadratic equations to solve applied problems. Let's take a look at this example here. In 1 3/4 hours, Cody rows his boat 5 miles upriver and comes back. The rate of the current is given to us as 3 miles per hour. We want to find how fast does Cody rows. Step number 1 is read the problem, which we did. Step number 2, we need to assign a variable. So in this case, the rate of the current is unknown, so I'm going to let that be equal to x. We'll let x be equal to the rate of the current, and it's a good idea to make a chart like this if you're going upstream or downstream, and write down distance, rate, times. Note that the formula for that, the distance is equal to be rate times time. So in this case, we're going to fill out what we know in this chart. We know the distance is 5, both cases, going 5 miles. And the rate, if you're going upstream, the rate of the river works against us. So here we would have the rate of the current is given to me as 3. So in this case, we have x minus 3. So we have x would be the rate of the current is 3 miles per hour. We want to know how fast would be the rate of the boat. So it looks like that we have a misprint here. We want to let x be the rate, not the rate of the current. It has to be the rate of the boat. This is a misprint here. We already know the rate of the current is equal to, it's given to me that is 3 miles per hour. So if you're going upstream, the rate of the current works against us. That's why we're subtracting that rate from the rate of the boat. But when we're going downstream, the rate of the current, which is the 3 miles per hour, would help us. So that's why we're adding this here. So the rate going upstream would be x minus 3, whereas the rate going downstream would be x plus 3. So note that the time, if I want to figure out what the time is in this case, if I divide both of the equation by r, the rate, then I can figure out the formula for time. So time would be equal to distance divided by rate. So the time that going upstream here would be the distance, which is 5, over the rate, which is x minus 3. And the time going downstream would be 5 over x plus 3. Now we need to write the equation. The time going upstream added to the time going downstream is given to us as 1 hour and 3/4. 1 3/4 hours, which is, I can write it as 7 over 4. 1 times 4 plus 3 would be 7 over 4 hours. So here is my equation. The time that going upstream, we figure, is 5 over x minus 3. And the time that is going downstream would be it would be 5 over x plus 3. These two should add to 7/4. That's given to us. So this is the equation that we need to solve for. To solve for equation, we find the LCD and multiply each term by LCD. So let's find out what the LCD is. The LCD, if you look at x minus 3, x plus 3, and 4, would be simply 4 times x minus 3 times x plus 3. I need to multiply each term. You have 1, 2, 3 terms by the LCD. If I write this down here, you notice that the first term, we have x minus 3 at the bottom of the fraction, reduced as x minus 3 as part of the LCD. So we will have 4 times x plus 3 times 5, which is 4 times 5 would be 20 times x plus 3. If I multiply the LCD by the second term, x plus 3 cancels, and then you get 4 times 5 times x minus 3, which would be 20 times x minus 3. And the last term, the 4 cancels, reduces to 1. You would get 7 times x minus 3 times x plus 3. So you notice that we're simply multiplying each term by LCD and we eliminate the fractions. You may want to, at the beginning here, make a little note that x minus 3 cannot be equal to 0. In other words, x cannot be equal to 3 if I add 3 to both sides of the equation. So these are the restrictions we have. We also have another restrictions here that x plus 3 cannot be equal to 0. So it means x cannot be equal to negative 3. So we're going to make a little note here. If I find x equal to 3 or minus 3 by solving this equation, I'm going to exclude them as part of my final answer. To solve for this, we simply have to distribute and solve for x by combining like terms. We all know how to do that by now, so let's take a look. Once you distribute and combine like terms, you want to get it into a standard form so we can factor them. You get 7x squared minus 40x minus 63. So in this case, once we factor them and setting each of these parentheses equal to 0, I would find x. Again, if you have a problem or question about how to factor, please review my sessions on factoring. Everybody should know how to factor by now. So here, step number 5, we want to state the answer. So the speed cannot be negative, so I'm not going to include minus 9/7 as part of my answer. So its speed must be equal to 7. So Cody rose at a speed of 7 miles per hour. And we can check the answer.